Good evening, Hare Krishna, Namaste. How are you?
Good evening, sir. We are fine.
Today we are starting our second chapter. Is matter around us pure? Have you studied this chapter earlier?
Yes, sir.
That's great. So, are you able to answer? Is matter around us pure? The chapter's name is lesser a name, but more about a question. It seems like a question. So let us understand, is matter around us pure? Scientifically, what science says, what is pure? Something which is made of same type of particles are known as pure.
Yeah, sir.
Same type of particles. For example, if you buy a packet of milk, do you think you have bought a pure substance, pure matter?
No.
What according to you are impurities there? Why do you
Milk
think
is
it's
a
not
mixture
pure?
of like a lot of
Mixture of
a lot of like it has a lot of things mixed.
how many things? Say some names.
Water,
Not sure. Okay, no need to worry. I'll help you. Just a moment. Is the audio and video good?
yes.
Okay. So basically, milk has water inside. Water is always mixed with milk. So if we see inside, and water itself is not a pure matter, pure substance. What do we mean when we say pure substance and same type of particles? Pure substance, or we can say pure matter, that's the same thing. A substance made of same type of particles. Same type of particles. Is a pure substance. We need to understand what particle we are talking about. Here particle means atoms. Here particle means atoms. Or molecules. Molecules. So when we say pure substance, we mean that the substance should be made of same type of atoms or molecules. You have a glass of water. What is the chemical formula for water? H2O, right? This is chemically known as H2O. What does that mean? That means H2O is made of two types of atoms. Made of two types of atoms. Which are two atoms? Hydrogen. Exactly. Hydrogen and oxygen. So there are two types of atoms and H2O is a molecule. Now the water that we have in the glass is made of same type of molecules, that is H2O. So this is a pure substance. Water is pure substance. Now if you mix some other thing with water, then probably it's not pure substance. Suppose you mix some milk into it, or suppose you mix some water into milk. Now this is not a pure substance. Reason is very simple. It is not having the same type of particles. It is not having same type of molecules or atoms. Water is a pure substance. Now you take any gold ornament. If you take any gold ornament, do you think it's a pure substance? Like in our houses we have many ornaments made of gold, made for example ring. Sorry, what did you say? Can't we call it substance? And this is why I taught you the first chapter. This is why I taught the first chapter. What I said, what is matter? Anything around us that is measurable, that can be measured, like its length can be measured, volume can be measured, area can be measured, anything. If it is measurable, it is a substance, it is a matter. Do you think gold can be measured? That's a substance, that's a matter. Did you understand? A matter further can be categorized as elements or mixtures. Elements, compounds or mixtures. Pure or impure. Is that okay? So I was talking about a gold ornament like a ring. If I have a gold ring, or like ladies wear earrings, necklaces, do you think these substances, I mean the gold used there, is a pure substance?
No.
Why do you think so?
Because pure gold is flexible and we have to mix something to make it like glue.
You said gold is flexible, right?
Yes, like pure
That doesn't matter. One moment. That doesn't matter. If gold,
we have to make something to make it like glue. So they don't.
So what according to you is mixed in gold? What according to you is mixed? No idea.
I think borax.
No. See, gold, pure gold is very flexible. Pure gold is very flexible. So ornaments can't be made of pure golds. If you create a gold ring that is made of pure gold, it will be deformed easily with a simple pressure, very little amount of pressure. If you just push it, the gold will be deformed, the shape will change. No one will wish to have that gold ornament, right?
Yes.
So what? Gold is mixed with some amount of copper. Pure gold is known as 24 karat of gold. Pure gold means 24 karat of gold. That is not preferred for making ornaments, jewelries. So 2 karat or 3 karat of copper is mixed with 22 karat or 21 karat of gold to make it hard, a bit more harder. If you mix 2 karat of copper with 22 karat of gold, then this gold is now known as 22 karat of gold. If you mix 1 karat of copper with 23 carats of gold, this is known as 23 karat gold. It becomes now a bit more harder. So now you can use ornaments made of these 22 karat gold or 23 karat gold. So the point is, the ornaments are not made of pure gold. This is not a pure substance. This is not a pure matter. So ornaments are impure matter, impure gold. I hope you understood it. It is not made of same type of particles. In this case, particle mean atom. We will discuss later how to know where particle becomes atom and where particle becomes element, compound, atom or yes, we will discuss about it later. So I hope presently you have understood what is a pure matter.
Yes.
Something made of same type of molecules, same type of molecules. Do you think it's a pure matter?
Yes.
And something which is made of same type of atoms, do you think it's a pure matter? So if we mix some amount of water into the with milk, why do you think it's not pure?
Because they have different particles.
Can you tell me what are the names of those particles? Can you tell me the formula?
I don't know the formula.
Milk is not a pure substance. Actually, I am not talking about the situation when someone being corrupt has mixed with some water into it. I am not talking about that situation. I am talking about a real situation, genuine situation where you have got milk from cow or any source. That milk even is not a pure substance, because naturally also milk has some amount of water in it. Is not a pure substance as it has particles. What does it mean by particles here? Atom or molecule?
Atom, molecule.
Not sure? One of you said atom, other said molecule, means you are not sure. Don't worry, I'll teach it later. Milk is not a pure substance as it has particles of water. Chemical formula is H2O. You said you don't know. And milk. What exactly is the milk? Milk is fat, right? So it has fat particles.
Milk also has fat.
Yes. So it is not made of same type of particles, same type of molecules. It's not pure substance. Now the next thing, let's move ahead. Let us see, if something is not pure, then what do we call it?
Mixture.
Right, it's mixture. If something is not pure, what do we call it? If something is not pure, we can call it mixture. Answer to this question is mixture. So now how to define a mixture? If it is asked what is mixture, how can we define it? What's the definition of mixture? Let's define it. Mixture. When two or more substances are mixed together in any ratio, this is known as mixture. When two or more substances are mixed together in any ratio, it is called mixture. What does it mean by any ratio? This simply means there is no fixed ratio that if you have 1 liter of milk, how much water you should mix into it. Actually, you should not mix water, but if you mix it, is there any ratio?
No.
No. You can mix half the amount of milk, like 500 milliliter of water. Do you think if we mix 500 milliliter of water with 1 liter of milk, they will mix up together?
Yes. Yes.
Do you think milk will have any objection with mixing with 500 liter?
They'll become a
That is not a matter. Matter is that they will mix up or not. They will mix up.
yes.
Okay, suppose if we have 1 liter if we have 1 liter milk and we are mixing 250 ml of water, do you think water or milk will have any objection to mix them together?
No.
They will not have objection, right? Okay. This is what happens in a mixture. Do you have any question? So both of them are known as mixture. Mixture. When two or more substances are mixed together in any ratio. In the first one, what's the ratio? 2:1. In the first one, ratio is 2:1. And the second one, what's the ratio? Don't you know how to find ratio? Okay, let me teach how to rate. No, wait, see, I'm teaching. 1 liter of milk, write 1. Half liter of water, write half. Now, remove the denominator by taking LCM and multiplying them to both. What's the LCM of denominators? 2. And I'm going to multiply both parts with 2. Tell me what will be the first part if I multiply with 2? First part?
2.
Exactly, 2 1 ja 2. Why to worry about that? And the second part? 1. If you multiply 1 by 2 with 2, 2 will cancel and 1 remain. So it's 1. That's why the ratio is 2:1. Now can you find the ratio of the second type? Still no idea? 1 liter of milk and 250 ml means 1/4 liter of water. Now LCM of denominators is 4. Multiply 4 with both of them. First part 4 1 ja 4. Second part 1 by 4 into 4. 4 cancels, 1 remain. 4:1 is the ratio. Ratio is not same. We can mix milk and water in any ratio. 2:1, 4:1, 3:1, 2:3, 3:2. It's your choice. It's your choice. For example, you take 1.5 liter of milk and you mixed it up with 500 ml of water. What's the ratio of milk and water? No idea? One liter means how many milliliters? How many milliliters means 1 liter? 1000? 1000 milliliter means 1 liter. So what do you think is 1.5 liter equal to? It's 1500 milliliter, isn't it? 1 liter means 1000, so half liter will mean 500. 1.5 liter means 1000 plus 500. It's difficult. 1 liter means 1000 milliliter and half liter means 500 milliliter. If you add them up, 1.5 liter is equal to 1500 milliliter. Is that difficult to say? 1.5 liter means 1500, 1500 milliliter. And we want the ratio of 1.5 liter of milk, 500 ml of water. This is 1500 milliliter and that is 500 milliliter. Now cancel out the common factor and you get the ratio. 00 cancelled, 5 1 ja 5, 5 3 ja 15, it's 3:1. That's it. Do you think any of them two will have any objection? Milk or water will have any objection? Will water say, I don't accept 500 ml of water, tell me, give me 600 ml, then I will accept?
No.
Will water say, I don't accept 1.5 liter, give me 2 liters of milk, then I will accept?
No.
So they have no objection, it's your choice. Whatever you want, mix as much as amount of milk or amount of water you want, mix them up. They will have no objection to mix up. So in any ratio, this is the meaning of the definition. Mixture, any two or more substances mixed up in any ratio creates mixture. Now let's move on to see the types of mixtures. What are the types of mixtures? Types of mixtures. Mixtures are divided into two types: homogeneous mixture and heterogeneous mixture. Homogeneous mixtures. Number 2, heterogeneous mixture. How to identify homogeneous and heterogeneous? What is the difference between them? Homo means equal. Homo means similar, equal. There are many words where homo word is used, like homeopathy. Do you know about homeopathy? Have you heard of this?
Yes. Yes.
It's a method of treatment. And do you know why is the name homeopathy? The name homeopathy is used here because no matter which disease a patient has, in most of the diseases, patient will get the same medicine in a different combination, only with a small difference, almost same medicine, almost. That's why homo word is used there. Okay, homogeneous mixture. Consider a type of mixture where two or more substances are mixed, but still the particles are not mixed up together. Like, take sawdust. Do you know what is sawdust?
Yes.
Go to any carpenter's place where carpenter is working. If he is working, you will get some powdered wood, that is sawdust. Powder of wood, lakdi ka powder, that is sawdust. Now take that sawdust in some amount, try to mix it with a glass of water, stir it properly with the help of a spoon. Do you think you will be able to mix it completely so that it can become invisible after some time?
No.
Not possible. You may keep stirring it for hours, 2 hours, 3 hours. Still you will notice the sawdust will never mix up with water. So this mixture is not homogeneous, that is heterogeneous mixture. They hate each other. They don't mix with each other. They hate. They are not ready to mix with each other. So they are heterogeneous. Now think of sugar crystals or salt crystals. Take some amount of sugar crystals, mix it up with a glass of water, stir it properly with the help of a spoon. Do you think after a few minutes or after some time you will be able to see the sugar or salt invisible?
Yes.
That's homogeneous mixture. When the particles are not visible separately, this is homogeneous mixture. But in case when particles are visible separately, this is heterogeneous mixture. Now let us write the definitions. Homogeneous mixture. It's a mixture in which particles of components, we can say those mixing items as components, a mixture in which components don't mix, homogeneous components mixes properly and mixes properly such that particles of components are not visible separately. Not visible separately. That mixture is homogeneous. Just contrary, just oppositely, if those particles are visible separately in the mixture, then the mixture is heterogeneous mixture. Heterogeneous mixture. A mixture in which particles of constituents, components or constituents are the same things. Particles of constituents don't mix properly and remain visible. That's it. So this is the basic difference. Particles of components not visible, then the mixture is homogeneous. Particles of the components or constituents are visible in the mixture, then the mixture is heterogeneous. I'm not talking about the situation when it is not mixed up properly. For example, you have a glass of water, you just put 2 spoons of sugar into it and don't mix it, you don't stir it. Then the sugar will be visible and then you will say it's heterogeneous, right? Actually, it is not about that situation. It is about the situation they are not being able to mix up together. It is not about the case when you have not mixed it properly. It is about the case when they are not able to mix up together completely. They cannot be mixed up together. Cannot be mixed up. Okay. So, if we take examples, example of the first one,
Salt and water.
right, salt water or lemonade, lemon juice with water, lemonade. Salt water, lemonade, etc. And for the heterogeneous mixture,
Starch and water. Sulfur and iron mixture.
okay, if I say milk
Boiling
with
water.
water, if I say milk with water, what do you say?
Heterogeneous.
Hetero or homo?
Heterogeneous.
Are you sure?
I said heterogeneous.
It seems you are not very much sure, right? You are making, you are changing your answer.
I said homogeneous. So Myra said homogeneous. I said heterogeneous.
Okay. So both of you have contrary, different, opposite answers. But those who said homogeneous, can you tell me, do you see the particles of water there? Do you see the particles there? Particles of water?
No.
No. Then how can you say it's, I mean, particles are not visible, right? How can you say heterogeneous? Those who said heterogeneous? Samaira, right? No, sorry. Yes. So, do you have any logic? Why is it heterogeneous if this is not visible?
Because
No worries. Let's add one more word into our definitions. Are not visible.
sun can be a uniform composition.
Uniform composition. Let me add a word here in this definition. Particles of components are not visible with naked eyes. Okay. Not visible. Okay, let's keep it as it is and add that word here instead. A mixture in which particles of constituent doesn't mix properly and remain visible. Just a moment. Sometimes they may not be visible with naked eyes. Yes, I have added here in the heterogeneous definition, sometimes they may not be visible with the naked eyes. Let's write example. Yes, tell me.
We can also write that heterogeneous mixture do not separate out.
Heterogeneous mixture do not separate out. Sure. So what about sawdust and water?
I don't know about sawdust.
Have you seen sawdust?
I have seen, but I have never mixed.
Okay, let's forget about sawdust. Let's talk about simply dust, soil dust. When you might have seen, if you are cleaning the floor of your house, you might have collected some soil dust, right? Next time when you collect soil dust, try to mix it with a glass of water. You will not, you will notice they will not mix up together. The dust particles will be floating all around and they'll be visible, still even stirring completely, properly.
They do not settle,
They do not,
settle down.
no matter settling down or not, they are visible still after mixing, right?
Yes.
That is important. If they are visible, they are heterogeneous, right?
Yes.
And if it is a heterogeneous mixture, do you think we can separate it out? Do you think we can separate
Yes,
them?
we can separate it. Like we can separate soil and water by filtering.
By filtering, right? By filtering
Sedimentation
or
technique.
sedimentation also, by
Sublimation
evaporation method also.
and sublimation.
If you sedimentation and decantation, right? Yeah, I was talking about evaporation. If you mix soil dust with water, then you heat it up, what will happen?
The
Water will water will evaporate and the dust
will remain.
will remain. So in this example we see heterogeneous mixture can be separated out just by a physical method. This was a physical method. Filtration, sedimentation, decantation, evaporation, these methods are known as physical method, not chemical method. So components of heterogeneous mixture are here being able to separated by physical methods, right?
Yes.
Okay, we have taken examples. Give me a moment. Next is to discuss about suspension. Suspension. What is suspension?
Like two substances state like heterogeneous oil and water.
Right. Suspension means the particles of constituents may remain floating, right, throughout the liquid or on the top of the liquid. Wait, before this, we should discuss about solution. Solution. What is solution? Homogeneous?
Mixture.
That's right. Homogeneous mixture of two or more substances. Two or more substances. Example?
Salt and water.
Right. Salt and water. Salt with water. We can say sugar with water, etc. So any homogeneous mixture of two or more substances is known as solution. In this example, notice that when you mix salt with water, there is something which is able to take up and mix inside it. And there is another thing which is not mixing something inside it, but itself is being mixed in another thing. Are you able to understand? One thing is in liquid form which has ability to dissolve other thing inside it, like water. Some other thing which can be dissolved in the another thing. Understand these two properly. So water here, water is what? Solvent. Solvent. And what is salt?
Solute.
Right. Salt is solute. So if we have to define these two words properly, solvent and solute, how to? Solvent. A substance that may be liquid or sometimes may be gaseous as well. A substance which allows other substance to mix with it, with itself. It is better. A substance which allows other substance to mix with it. Is this meaningful?
Yes, sir.
It may be liquid or it may be gas. It may be a liquid or a gas. Now let us define solute.
The solvent has more quantity than solute generally.
Sorry.
Solvent has more quantity than solute generally.
Generally, that's okay. So do you want it to be included in the definition?
No.
Okay, that's good. Solute. A substance that can dissolve with solvent. A substance that can dissolve with a solvent. is called solute. It can be what?
Sugar and
It can be solid, liquid, or gas, right?
yes.
Okay, one example we have already taken, salt and water. Do you have any other example, any example where the solvent is gas?
Like LPG cylinder.
LPG. That's okay, because in this case solvent is methane. The main substituent is methane, that is solvent. We have to mix some other thing for a smelling purpose or some specific purposes. We mix something else with it, like ethene, methane plus ethene. There are two gases actually inside LPG: methane, ethane, not methane, sorry, that is methane. Sound N, A-N-E. Methane is mixed with ethane along with another gas, that is for smelling purposes, because methane, ethane are not having any particular smell. If sometimes gas cylinder leaks in our houses, we'll not be able to detect if this much big accident may happen. We are in danger, will not be able to sense it. So for this, for the security reasons, there is a specific gas mixed with it for smelling purposes. After mixing it, if it leaks from the cylinder, it will smell bad and we can detect something is wrong, we can make it correct. So yes, that is another example. Air can also be pure air. Air is another example.
Because it has nitrogen 70% and
Exactly, nitrogen is mixed. Yes, nitrogen, hydrogen, etc. So that is another example. I'm writing it here. Another example, air. Okay, so now we know about the solution, solvent, solute. We take solvent, we take solute, we mix the solute with solvent, and as a result whatever is prepared we call it solution. So finally we can write here solute plus solvent gives solution. Now we can move ahead towards suspension. A heterogeneous mixture in which solute particles remain suspended throughout the solvent. That is called suspension. Um, what can be the example of suspension?
Chalk powder and water and sand
Which powder?
and chalk water. Chalk powder.
Chalk powder. That's good. Because sawdust example is not good. Sawdust remains floating on the top only,
Sir,
but
I
it
said
gets sand.
yes.
Sand is also good. If it is very fine particles of sand, it may remain suspended throughout. Bigger particles may settle down quickly. So that will not be a good example then. If we take fine particles of sand,
Soil and water.
that also may be, but only those smaller particles which remains floating. We cannot consider those particles which either remains floating on the top or settle down in the bottom. Those particles which remain suspended throughout the solvent will be considered as the solute in that case. Okay?
What it appearance looks like.
Sorry? Appearance.
What yes. Okay.
Appearance, okay. Have you visited any river ever? River?
But I have
If you have visited a river, you might have noticed river water. When it is disturbed river water, in most of the cases river water or pond water, you can collect water from any source, any natural source like a pond, a river. You will notice that it is having some floating particles throughout the water, not only on the top or bottom, throughout the liquid. That is an example. Or if you want to prepare suspension at home, you can take some sand, mix it with a glass of water, leave it for a moment for some time so that bigger particles can settle down and very lighter particles can be floating on the top. Remove the top layer by sedimentation and decantation process, and bottom particles also by the sedimentation and decantation process. You have removed now the top and bottom layers. Now still you will notice there are some sand particles, very fine particles, which are neither on top nor in the bottom. They remain floating throughout the liquid. This is how a suspension looks like. Got it?
yes.
These particles remain visible with naked eyes. These particles remain visible with naked eyes. Naked eyes. Is that okay?
Yes.
Just a moment. Okay. Next item is, after suspension, it is colloidal. Colloidal solution. We can say colloid or we can say colloidal solution, that's the same thing. You just say colloid or you say colloidal solution. Colloid or colloidal solution. This is also solution itself, solution. Just a moment. A heterogeneous mixture in which particles of in which solute particles are smaller than that of suspension. And remain floating throughout the solution. Did you find any difference between suspension and colloidal by going through the definition?
Yes.
What is the difference?
That particle separation and the particle remain suspended throughout. And they cannot be visible by.
No, that is the same thing. If you say floating throughout the solution, here also suspended throughout the solution, here also that's the same thing. Difference is here. The particles of the solute particles of a colloidal solution are smaller than that of suspension, and so they cannot be seen with naked eyes. Because of being smaller particles, you cannot see the solute particles with naked eyes. When you see mixture of milk and water, are you remain able to see the particles of water or milk?
No.
That was our earlier discussion. We were talking about how to make this decision whether the solution of milk and water is a suspension or colloidal. How to make this decision? Is it a heterogeneous mixture itself even, or a homogeneous? That's another question. First we have to make a decision whether milk and water solution is a homogeneous or heterogeneous. If it is heterogeneous, why don't we see those particles? Actually, milk and water solution is a colloidal solution. The particles are so small that we cannot see them with naked eyes. We cannot see those particles with naked eyes. Then what? Then what is the other way to see those particles? Is there any other way? Yes, there is.
Yes.
There is any way. There is a way through which, using which, we can see the particles of colloidal solution.
By time. By time.
By?
By time.
I'm not able to understand that word you are saying.
By Tyndall effect.
Tyndall effect. Yes, Tyndall. You are saying Tyndall. Right. That is called Tyndall effect. Correct. We can use that. So the basic difference between suspension and colloidal is that we can see the particles of suspension with naked eyes, that is a heterogeneous mixture. Colloidal solution is also heterogeneous, but their particles are smaller, solute particles are smaller than that of suspension, and due to which we cannot see the particles with naked eyes. That's right, and we can see this with the Tyndall effect. If we project a beam of light, we allow beam of light to pass through that, the particles will be visible. Okay, now today we have to stop here only. We'll continue the discussion in next class. For now, bye bye, take care.